Sixth example, or second for completing squares. We have integral of dx out of root minus x squared minus 2x plus 3. I'm going to write this term minus x squared minus 2x plus 3 under square root again on this second side of completing squares. So remember, just like last time, I'm only picking what's inside, so I'm interested in this, not the square root. The square root remains whether even after completing squares. So negative x squared minus 2x plus 3. Pull out the negative for only here. Leave the 3 out of it. It doesn't. You can involve the 3. You can. You know what? Let me involve the 3. So when I pull out the negative, I'll have I'll have x squared plus 2x minus 3. So at this point, I'll now have to look at the coefficient of x, which is the 2. Remember, coefficient of x, half the coefficient of x. Then the answer you get, square it and subtract it. But this last part has to be done within the equation. So negative x squared plus 2 times 2 out of 2, I should have written 1, but okay, 2 out of 2 x plus 2 out of 2 squared minus 2 out of 2 squared, don't forget, minus 3. To simplify this equation, x squared plus 2 times 1, I could just write it, 1x plus 1 squared minus 1 squared minus 3. So just like last time, we're looking at this, having these 2 terms as our 2 terms of the equation. So that means with the brackets, our perfect square is going to be x and its second term positive 1, and then the rest of the equation, which is negative 1 squared minus 3. So negative, big brackets, negative of x plus 1 squared, this is going to become negative 4. When you put in the negative again, open the brackets, this will be negative x plus 1 squared, the negative and the negative will give you positive 4. And this is the new term. If I rearrange it, 4 minus x plus 1 squared. When I go back to my equation, put a line. Going back to my equation, I rewrite this. So dx, I'm writing the new terms which are with the completed square version. 4 minus x into x plus 1 squared. Then I have to just continue the normal way. This, of course, looks like the second part, so I'll use the second method. So this will equal to du root of a squared minus u squared. Side work again. Our a equals to a squared, equals to 4. So our a will equal to 2. My u squared will equal to x plus 1 squared. So my u will equal to x plus 1. And my du will equal to dx. So coming back here, that means my sine inverse u will be x plus 1 out of a, which is 2, plus a constant c. Inverse x plus, I'm just rewriting it down here so that it's away from all that mess. And this is the answer. I think I'm still sticking to my point. The approach is not that hard. If you've understood, you can continue with the questions down for more practice. Or if you haven't understood, please leave a comment for me to post more videos in relation to completing squares in sine substitution.